Hello everyone, welcome to my first programming project video. Today I will show you my attempt at simulating emergence with a program I created in JavaScript called Particle Life. I first got this idea from IZ Gartlife's Primordial Particle System. Fascinated with their simulation, I dug deeper and found a code parade video about how to create a similar system known as Particle Life. I decided that I would like to create something like this to start off my programming series, where I just document all my little programming projects. So what is Particle Life? Well, it's a simulation of emergence. You create a particle system that operates under simple rules, and complex, self-organizing structures emerge from the chaos. But what is emergence? Emergence is pretty much where complex and abstract entities are formed via a system of simple rules. Kortzkasart has an amazing video on it, if you're interested. An excellent example of this is with ants. Ants are stupid. They can't do much on their own. They follow out simple rules that are driven by instinct. However, a bunch of ants are smart. Together, ant colonies can keep crops, wage war, and defend themselves from invaders. Ant colonies are an emergent entity that is formed from the simple rules that all the ants follow within it. Okay, so how is this going to work? In our simulation, we have particles. A particle has a type denoted by its color. Particles of one type have a random attraction and repulsion with every other type of particle. For example, a red particle might repel blue particles, and blue particles could attract red particles, while yellow particles might be repelled by both. This can break the law of conservation of energy, as well as Newton's third law, as green particles, for example, might be attracted to purple, while purple is repelled from green. This creates a situation where green is constantly chasing purple. To stabilize the simulation, we add a drag force that will slow down particles to prevent insanely fast speeds that ultimately lead to a boring simulation. Particles also have a range dependent on their type. They will only affect particles within their range. Okay, with the rules in mind, it's on to the implementation. I started off by creating a particle class. This class contains variables for position, velocity, acceleration, type, and attractions. I created random attraction values for the different types, but did not implement motion yet. I made the particles have a random color based on their type, and drew it all to the scene. I started by creating 100 particles scattered on the canvas randomly, with 5 random different particle types. With that looking acceptable, it was on to the physics. It started off simple, and to be honest, it should have finished simple too. But I'm really not good when it comes to math, so it was a struggle for me. I made it 10 times harder than it really needed to be. But I started off by just implementing velocity, acceleration, and just simple motion in general. Then it came to applying forces. This is where it all came to a grinding halt. I had to use trigonometry to find the angles at which to apply the forces. I am notoriously bad when it comes to trig and angles. After an embarrassingly long time working out what was wrong with my forces, I finally found a solution. It wasn't pretty, but it worked, so I went with it. I added attraction, repulsion, drag, and small extra force to help prevent collisions between particles. And with that, the simulation was basically finished. I just needed to polish the results now. When I saw my creation come to life for the first time, I was shocked at how well it turned out. I saw 1,000 little particles start from chaos and randomness, and watched in awe as lifelike arrangements emerged from it. I saw groups that resembled cells with membranes and nuclei, groups that looked like worms that would move around. I saw creatures that would eat particles around them and grow. Look at this guy, he looks like a hairy ball, and I love it. But wait, creatures? I never programmed a creature class. I only programmed particles with randomized attractions to each other. This lifelike behavior all emerged from those simple rules. There are no creatures, there are no cells, no worms, nothing. These abstract entities all emerge from particles and their simple interactions, which is why I find emergence to be so incredibly fascinating. Thanks for watching.